NTU World of Wisdom. Welcome to High Impact Thesis. In this podcast, we speak with researchers from various scientific fields to talk about the motivation, goal, and potential impact of their research. We also want to give you a sense of how a Ph.D. is carried out with an emphasis on the PH, the philosophical aspects involved in pursuing a Ph.D. Welcome to the High Impact Thesis podcast. Today our guest is Mr. Krishnan. Krishnan, we appreciate you taking the time to chat with us today. And as always, we hope that you can share with us as much as you're willing to share. We've got a couple of questions that are guiding questions, but we want you to be very comfortable and just take the conversation in a direction that you feel would be much appreciated by the people who will be listening to this conversation. So thank you for being here.
Thank you so much, Christopher.
All right. And so the way we start the podcast is that we generally want to get a sense of what it is you're doing in a very general sense. That is, you meet somebody and you just want to give them a quick overview of what your work is about. What do you tell them?
Okay, as introduced, I'm Krishnan. I'm finally a PhD student from School of Civil and Environmental Engineering. And my supervisor is Prof. Yanganhua. And we have a group called Living Stone, which literally says list at NTU. So as the name suggests, we work with different kinds of concrete or construction material to enhance the durability or sustainability or any properties of the existing concrete.
Okay. And what's the name of the lab again?
Living Stone.
The name of the lab is Living Stone?
Yeah.
Okay.
Nice.
Okay, interesting. And there's a Livingstone who went to my country. But have you heard of David Livingstone though? No? Okay. He was an explorer. No, he was an explorer way back in, I think it was 2 centuries back. So
okay. This Livingstone is very famous name, I think.
Yeah.
The last name.
Okay, so you're working with or in the field of construction materials.
Yes.
Right. Do you actually go out and do any of this, or is it more lab work and more computation and more slightly more detached from the actual construction today?
So when I joined the group, initially we were doing almost lab work.
Okay.
Just pure research work.
Mm-hmm.
But 2 years ago, we started introducing this newly developed product into the industries.
Mm-hmm.
So we have LTA and JTC, Land Transport Authority, and Jurong Town Council Corporation.
Okay.
So we collaborated with them for making some pavements on the road, just normal concrete pavements.
Okay.
As you can see that on the junctions of any road, you can see some different pavements. Rather than the black, it should be like grayish kind of thing, because there it's more important. The normal pavement won't be good, so they're not durable. So they prefers concrete pavements over there.
Okay.
So we developed a new concrete called bendable concrete, which you can literally bend like a road without any major cracks. We have minor cracks, but yeah. Okay. With this material, we try to put some pavements, and then we try to test how in the real life how they performs when compared to the lab works, and that project is still going on. Okay. So I would say that I was very lucky to join a group where we could take some products that we developed in the lab to a real application.
Okay. So could you tell us a bit about the overall motivation for this research in terms of the specific problem or the specific research area you're in? Right? We've been doing construction for a couple of thousand years, and we've been using some materials for a very long time. Could you tell us why there is need for a new material, and whether you were specifically targeting some problem? I don't know whether it's at the corner or what was the motivation overall?
Okay. So before that, I would like to introduce that I am working on sustainable construction materials. So the problem with the current concrete is that we use cement because it's well established material. And if I talk to you about concrete, the first thing that comes to your mind is cement.
I didn't even think of anything else.
That's another thing, right?
There is other kinds of concrete.
Okay, so that's the point. Like the main perspective is that it's just cement.
Uh-huh.
So the problem with the cement is that when you produce 1 ton of cement, 1 ton of carbon dioxide is generated.
Okay.
That's a huge issue because it is number 2. It is in the number 2 position for contributing the carbon dioxide production in the world. And with developing countries like India, China, where they are investing a lot of money on infrastructure development in a large scale, this trend is going to increase. The consumption of cement is going to increase, and consumption of basically concrete is going to increase. So there is a need for developing new materials which doesn't have the impact, like negative impact, like cement.
Okay.
Of course the material is good, but moving further, we are facing climate change and a lot of issues related to that. So we need an alternative material which is more green, which is sustainable, which is as good as cement as well. So that's why in our research group we focus more on like alternative materials using byproducts from the industry and natural resources like clay to make cementitious material. We call it concrete basically.
Okay. I mean, interesting. So when we talk about concrete, what does the name mean? Or because to me, it really, the thing that comes to mind is just cement. What is concrete? It's a combination of...
Concrete is like a composite material, like you have a cake. Okay, cake could be anything, like chocolate cake if you put chocolate, vanilla cake if you put vanilla. So concrete is just like that. The main ingredient is of course cement and water, and then you have additional substances depending upon the functionality of the concrete.
Okay.
So we use concrete for different purpose. So depending upon the ultimate function of the concrete, we add other materials like a coarse aggregate, the stones basically, sand, maybe some chemical admixtures in specific applications. Or nowadays we are also adding some recycled plastic materials to reutilize the plastic.
Okay.
Basically you can add anything in the concrete, whatever you need actually.
Okay.
So it's a very heterogeneous material.
Okay. I want to stay a little bit on this general theme of construction materials. And from the little reading I have done in construction, people have been constructing for quite some time, way, thousands of years. And we still seem to see some structures that were built a couple of thousands of years back. So I'm wondering what has changed overall. Maybe you can talk about concrete, but also you can talk in general. What are the key materials that humanity has invented, and what was there that is not there anymore? Like generally, what is the evolution of construction materials from when we started recording history to about now?
Okay, that's a
big picture question.
I mean, it's just I want to get a sense of what's going on.
So I think it all started with Rome. According to my memory, they started using this limestone clay to make basically calcium carbonate. So they use that material to make buildings. But then I think it was in Portland. There was a place called Portland or somewhere like that.
Portland.
Yeah, they basically made a new material where you just need to add water to make a glue-like substance, which was very easy.
Okay.
But the process was long, but the ultimate product is very easy. You need to make something, you just need to put cement and water. You get a glue.
Okay.
And then after some time it hardens. So that's a very good material. Like unlike take for example, you need a sphere. If you have steel, you need to melt it and you want to make it sphere. But here you have a material, you can make it any shapes. But the thing was, concrete is like a brittle material. It has good strength, but it is very brittle material. So in order to develop that, it had like 100 years of research, or 150 or 120 years of research.
Okay.
The way that stands now is very different. Earlier you had like it can take 10 megapascal of strength.
Okay.
Now you have concrete which can take like 200 megapascal of strength.
I see. I see. Okay.
And the major difference was right now, because I mentioned you that about cement produces a lot of carbon dioxide when it is manufactured.
Yes.
So they started to think this on more how to make this particular material more sustainable, because earlier it was like, okay, just use. We'll have more cities, we'll have more infrastructure,
Right.
don't care about climate. But the past 20 years of research or past 30 years of research is like, how can we make concrete a material, how can we make concrete as a multifunctional material rather than just a structural material. So like adding more function to this material, apart from just a building material. So nowadays you have concrete which can self-clean itself.
Okay.
There are some church filled with TiO2, like mixed with TiO2, it's a titanium dioxide basically.
Okay.
So you have self-cleaning property. It can, if any dirt is there, it can wash itself.
Okay.
When the water drops, like it just cleans it itself. You don't have to clean it. And then you have cool, we say cool painting, but also we have cool slabs, which is you can reflect a lot of sunlight, and then you can create an optimum temperature inside the room. And then you have self-healing concrete, like it can heal itself. When it's having a crack, over the time it heals itself. You don't have to repair the concrete.
So all these properties are defined through using different
materials that we add on to the concrete. So it is,
I see.
now the concrete is not anymore cement and water and coarse aggregate.
Okay.
It is more about chemistry. How can we so it is reverse process. What is my ultimate function of this particular product? I need to withstand this much strength. Also, I need waterproof.
Right.
So basically, I design according to myself. So the way it came was incredible, because it is the most used material in the world, actually, concrete. So
does that produce a lot of resistance as well? Since folks out there have been using concrete for a long time, and then you are the researcher and you come in and tell them, look, I have a better material that can self-clean. Do people understand, as in the real world where they have to build these large projects?
I think this is always been a difficulty for any researcher who want to come into the market and say that, hey, I have a better product, but the price is different. Because concrete has been here for like 150 years and well established. They have standards. The problem with not the problem, the main disadvantage for us to bring any material into the market is the standards.
Okay.
Because you have concrete is used for building infrastructure or like houses or something like that.
Right.
And the safety of the people depends upon how safe your material is then.
Exactly.
And this is a well-developed, well-established, standardized formulas. Everything is there. But you have a very new material which you don't know what happens in long run. So when you compare the safety, they don't want to use the new materials. I think this is the biggest challenge that our group is facing also, because of the standards.
I see. So by working with I guess entities like LTA and JTC, I guess that sort of helps. It's like you have someone who would want the same as you, like you want the good buildings and so on.
Right. Are these standards global, or are they different from country to country?
Yeah, it's different from country to country actually, because every climate or every surrounding systems are not same. When you compare Europe, it's gonna have when you compare Europe and a tropical climate like Singapore, the temperature is so different.
So basically, you need to factor in the climate differences.
Yes. So so the standards would be different. Like any materials, they have different standards. They have Euro code, they have American code, they have Japanese code, Chinese code, British standards, Indian standards.
Okay.
Yeah, each country have their own standards.
Cool. Anyway, so thanks for giving us the general overview of materials and construction in general. We would like to now delve a little deeply into your own work. What is it that you do? And, we also later on maybe would like to hear about what are some general things you've learned about doing research that you can share with our audience. But let's start with just what do you do? What angle are you approaching your problem from?
So I have mentioned about different functions of the concrete.
Yes.
So one of the function that we focus is, my research focus is self-sensing concrete.
Okay.
This is something that I've presented recently, and I'm very excited about it actually. So the infrastructure, as we know, that infrastructure over the time it degrades, and then you need to repair it, and it costs a lot of money from the government to repair these infrastructure, billions of dollars actually. Right now we have structural health monitoring system to help out this issue. So they place sensors onto the structures to detect the changes in the concrete. So if any abnormal change is detected, they can repair immediately so that there won't be any damage to the entire infrastructure.
So these are mechanical sensors, like they bend,
Yeah,
that sort of thing?
the strain sensors, normal strain sensors, or like they have optical fibers now to do the work.
Okay.
Yeah, they have lasers now. So there are different technologies that exist now. But in the past 10 years, they also saw that the concrete can itself do this work. Like they can sense certain changes in them. The basic behavior we call is piezo resistance behavior. So the
Say it again.
piezo resistance behavior.
Oh, yeah, piezoelectricity. That's
Like piezoelectricity, you get an electricity when some external loading is applied.
right.
But in piezo resistance, you get a change of basic resistance when some loading is applied due to several reasons. So what happens is concrete have this behavior basically. So if you give an external loading, you can see the changes in the resistance values.
By the regular concrete?
Regular concrete.
So when we say regular concrete, we're talking about cement as the main component.
Cement.
Right?
So
it can do.
You can use the material itself as a sensor to give you an indication of the load.
Yes.
Interesting.
But the problem with this is we need to add a lot of fillers, additional fillers to make this work in the concrete, in the cement, because the property is there, but it is not very evident, very clear to use it as a sensor.
So you need some sort of amplification, perhaps.
Yeah. But with our material that we develop, which we call geopolymer concrete.
Geopolymer concrete.
Yeah. As the name suggests, it's kind of a polymer-based material, inorganic polymer material. And it doesn't use any cement, basically. We make the glue material without using cement.
Okay.
We use metakaolin. It's a clay, basically.
Okay.
And some activating solution to make like glue material. I will use glue material because if I keep adding cementitious material, it will confuse. So we found out that this material have enhanced piezo-resisting performance compared to the cement, and also it is comparable to the existing strain sensors, electric gauges, actually strain gauges. And also we found out that this material have similar properties to that of a semiconductor.
Okay.
So we wanted to further deeply understand what's happening when you have different mixing parameters, and to identify mine is very chemistry and like microstructure material science based. So we understand the microstructure of this particular material, how this behavior is exhibited, because if you look it from outside, it's just a concrete material, cement material, but the performance is 100 times than the original cementitious material. So I'm trying to understand how this material is behaving, and what if I add some more other additional substances? Whether this behavior would change or not.
So do you do both computational microstructures, look at them on the computer and make predictions, or is it more you go in the lab and mix things up and then measure the properties?
We don't have much data for this particular material, so what we do is now all laboratory based work. To make more data, you need experimental work. So it's a completely lab based work, and I love that actually. I'm not a guy who likes computational thing. I absolutely love lab work because I can really see what's happening. So
And because there's also, from what I hear, the construction industry is one of those industries that is generally reluctant to adopt very novel technologies. Because I guess one of the things you mentioned just a moment ago is that it's about the safety of the people,
Exactly.
right? So no one really wants to be the one whose building falls apart because they use some novel thing. So I guess working with it with your hands and actually touching it, I guess, makes it more concrete for you as well.
Mm-hmm.
Yeah, the safety is the important thing. Often we into this. Okay, let's not deviate from that. Yeah.
Okay.
Sorry.
But okay, so I'm wondering, as a researcher now, obviously you have been here for some time. You've picked up some tools and techniques of doing research. Could you share any that have been useful for you navigating research life? These don't need to be specifically for concrete. Just general.
Yeah, just general. Okay, I think this is a very good question. I don't think I have a straight answer for that. But when I started my PhD and he gave me multiple topics and I choose one, and then I was giving a presentation I remember 2 months or something like that.
Mm-hmm.
I list out, okay, I wanted objectives. Objectives was fine, and then I list down my scopes. So I said I will do this. I will study that. I will study this, and 1, 2, 3, 4 different objectives. Basically, he didn't say much. He said you can go much deeper. You just let me know after 1 week. We can have again a discussion. Then I was again reading, and I found out that each topic is actually a PhD topic
by itself.
Yeah, by itself. This I didn't realize. He mentioned to me in the next meeting. Recently, a new PhD student joined in my group. And he was giving his PhD objectives and scope, and I could see that the same thing that I did. I was giving, he was like, I can do this, I can do this, I can do this. Then I immediately I was like, I think each one is kind of a PhD topic. You can go much to the. So that's the difference. So I was very I wouldn't say naive, but I was so excited that I wanted to do very novel research, nobody have ever did it. That's the first one, I'm gonna do that.
Right.
That kind of thing. Because always people give you an impression PhD is something new.
Right.
But over the time I realized, and also from my prof's understanding and discussions, I understand that it is not about the topic, but it is about how you do the research. It's a journey of how it teaches you how to do a basic research. It doesn't teach you to build a new material or to have an innovative material, but it teaches you how to do a proper good research.
Yeah,
And I think we all been there.
yeah, for sure.
Yeah. First, I was also thinking about when people say that, oh, I had the conference, I had the publication. So it's okay, second year I should have 2 papers. Third year I should be having that. But then over the time you realize that having a quality research is important than a very quantity-based research. It's not about number of publication, but it's about the impact of your knowledge.
Yeah, correct.
What you have done through the PhD is also very important.
In fact, today I was at the conference. I think it's called Material Research Conference that's happening in Singapore now. During this week, and people were talking about how do you actually measure the impact of the research that we are doing, right? And the joke was that you could say that you want to look at other things other than how many papers you have published, or whether it's an impact factor, the journals and so on. But it's a little, maybe at an administrative level, it's not as easy to implement perhaps, because papers are you can count, okay, did 200 papers. So it's very clear then. Yeah. But the other impact, obviously we can measure other kinds of impact. But sometimes the other impact takes long. So you do your research now, and maybe you win a Nobel Prize 20 years later, right? And so we won't know now that you have this incredible view of the world.
Exactly. That's why it is known as Doctor of Philosophy rather than like Doctor of Innovation or something.
Right. And in fact, this podcast is about the philosophical aspects of research. So I think we've talked a little about your research and what you do in the lab. And so I think now we'll move to more of the philosophy of things. So I'll let Mohammed
talk
take
philosophy.
over.
Yeah. So I think now we can move on to the bigger picture of things. So I want to step back to something you just said about using the, like, it's more relevant to your own work. You said something about using the concrete itself as a sensor for the load. So I just wanted you to tell us a little bit more about that, and then we'll take the conversation in a very specific direction.
Okay.
So what kind of material property that allows you to do that?
Okay. Basically, when we look at my material, it is, if I say very clearly, it's aluminosilicate. It's an aluminosilicate binder. So it's with silica with aluminum bonds.
Yeah.
So if you look at the semiconductors, you have, if you remove one silicon atom from like 4 thing and put aluminum, it's called some doping is there. I don't remember that. So it's kind of what we believe from our understanding is like kind of a semiconductor, but we are not able to explain because it is a cement based material. So for all the research that have been done, they try to bring out the theory that has been applied in metals. Like in metals, they say that when you compress, the metal shrinks, and because of now the distance is shorter, so the electrical resistance is low because the distance is shorter for electrons to move. And when you pull, they will be like the distance is more, and then the resistance is high.
All right.
So they say that because the whole thing changes, the shape and the size of the material changes. Yes.
So it changes the electrical properties, or what exactly?
Yeah. So it can change the electrical properties.
It can, and this can give you an indication of the load.
Yes, it can give you the identification of load, or if the concrete is wet. Because the dry concrete doesn't have high resistance. If the concrete is wet, then the conductivity is much higher. If any crack is there, then the electrons cannot pass through. There is a distance, right? So we are trying to correlate that. But apart from that, we believe that we have to apply some kind of theories that is applicable to semiconductors to my material. We are taking that path to see that whether we can explain certain kind of behavior, of this enhanced behavior, using the theories that from semiconductor. And that's my biggest obstruction now, because I am a civil engineer and I'm going to, and that's the beauty of PhD itself, because sometimes you don't know, like you have to take other disciplines theory to explain yours.
I see. So in terms of the applications, now I want to move on to the applications of these kinds, like the potential applications of this kind of research. So in your view, what do you see as the potential future applications for these materials, whether it is in construction or maybe perhaps other kinds of applications?
Okay. One of the important application would be using it in pavement. So in the pavement, in the interjunctions, you can find out, using this material, you can find out how many number of vehicles are. Basically traffic monitoring. Let me put it in some way. The pavement is going through completely cyclic loading. It's not like in a room, a slab, like this slab, the place where we are sitting. This will not have a continuous loading. Whenever people come in, a small loading will come. But in a pavement, it's a constant load, like the vehicles are moving through. So the durability of these kind of pavements are very low. And if you can't find out the cracks in the initial stage, you don't have to do bigger repair. You can save a lot of money in that way. But over the time, these cracks will become big, and then you need to change the entire structure. But if you find out in the initial stage, you can just repair like normal repair you can do, and then it can go again for another 20 years.
So it's an early intervention to fix the problem before it gets worse.
Yeah. So now what they do is they go and check physical inspection. Physically, or like drone. Nowadays they are using drone also to use these things. But with this material, you get a constant data. If I have a good data acquisition system, then you get a constant monitoring of what's happening. If you can see any abnormal patterns, then you know that okay, there is something there, and you can change it. So,
I see. So historically, like in the past, people have always been doing the visual inspection, right?
yeah, one is visual inspection. Another one I mentioned, using the strain. In the bridges, they use strain gauges.
Strain gauges. These
Yeah,
are sensors, right?
Yeah, sensors.
Okay.
To measure the differences in the displacement or any abnormal stress is there.
I see.
And is this data sent out, or they like right now? I guess with the network and connectivity, is there sensors that then talk to another, I don't know, central server, or is it more you still have to go and actually go read the values?
So this whole process we call it as structural health monitoring. The whole process. So in structural health monitoring, we have three different things. One is sensors, and another is data signaling, and then a final thing is data collection or something like that. So now we have different ways to collect the sensors. Like you go there and collect, but now people are working on wireless sensors. Like you can get the real-time data without going there and checking. But those are everything is on research process, like not very well established, and that's what I'm telling you. Like now we are doing the research; it might take years to be applied. That's the thing.
But it has a huge potential, primarily in the area of monitoring buildings and bridges.
Definitely.
And saving a lot of cost in terms of resources.
Yeah, because you don't need another sensors attached onto the surface. You can use this material as a bridge slab, and then also you can use it as a sensing material. So that's what I was talking about, like multifunctionality of the same thing.
So it's not just structural property, like it can take this much load, but it becomes much more intelligent.
Yes, smart concrete. Yes,
Okay.
we are going to
That's
smart
nice.
concrete, smart infrastructure. We have smart cities, smart countries, smart infrastructure. Now,
Right. So
smart concrete.
Smart concrete.
Let's make everything
Alright.
smart.
Smart everything. I like that. Okay. I'm actually interested in general in the roads in particular. I'm sure concrete is used in a lot of areas. But from the readings I have done, and also from what I see here in Singapore, there are quite a great variety of roads. There's the brick roads I see a little bit of. I see some places they have tiles, and some places they have concrete, and some places have asphalt. From your reading, since you're in this field, I'm wondering, what would you say really determines which one is ideal? Is it just climate? Is it more finance? Is it just technical ability? Or because I see quite a combination of these across Singapore, for example.
That it goes back to what is your ultimate not aim, I would say, like what is the final application of that particular material. So we have asphalt road and concrete road. These two are the very common roads that we find in Singapore. And brick roads, we may use it in parking lot, something like that. The advantage of asphalt road is you can lay now and open it for public. But in the case of concrete road, you lay now and you have to wait for another 21 to 28 days to open it for public. But the durability, I'm telling different pros and cons of these two, but we cannot say that concrete is better than asphalt and asphalt is better than concrete, because the purpose is different.
Right.
But the asphalt, the durability is very low, 5 to 10 years.
I see. Okay.
Yeah. But the concrete can go to 20 to 25 years. And asphalt needs constant repair because it depends upon the loading cycle on that particular place.
Okay.
So in a normal, as you can see near the junctions, what happens is the buses applies brakes, like the vehicles applies brakes, right? And that particular time there are more force exerted on the road.
Oh, I see. I mean, I was wondering what's up with the junctions. Why do they matter? So it's mostly the stopping and the starting.
The braking.
So it's okay.
So that's why you can see one side concrete, another side is like normal asphalt, because that's just passing. Where you apply brake, there it will be mostly concrete pavement. So there you need high strength, or like it can take more loading cycle. We say sometimes fatigue or something like that, because it's a constant cycling, like friction, a lot of things. So there people prefer concrete road to have more durable pavement rather than asphalt pavement. And also in the best base they prefer concrete, because that's where the buses again break or like something like that. And also this is applied where heavy vehicle, like most of the Jurong Island area, where it is like a lot of heavy trucks passes by, or like near shipping yard, there they usually use concrete, and also runway they use concrete.
Okay.
So heavy trucks are usually problematic for roads, right?
Yes, even for concrete roads.
Even concrete.
Yes.
Because I hear that brick roads can stay for a century, so that's why I was wondering why don't we have more brick roads? So that's why
It's difficult in laying, actually. Laying out of brick road is very difficult.
Oh, okay.
I saw recently there is a new machine that can just lay like brick over the brick. I just saw it. They make the payment with brick using a machine. It is very simple. But if you see, as I mentioned, it is like the safety and the standards. It's very difficult for a new market vendor.
Yes. And of course, why you're doing it, right? So if so some things work better in depending on the function.
And in Singapore, to get also depending upon place, like the local availability of the material is very important. Like if you look at it, Singapore is a small island, and I don't think here anybody makes bricks, so you need to import bricks again. And if you look at the price of 1 kg of cement is just around 0.5 cent, I think. It's around there. Okay. It's less than $1.
All right, so towards the end of every episode, we like to stray away from the research and academic life and ask you personally as a PhD student. So I'm sure you have a very busy schedule. So what kind of things or interests that you like to explore in your free time, or what kind of activities you like to be part of your free time?
Three things. One would be dance, actually, definitely, because I'm learning dance from my childhood. It's always been a safe place for me to just go and de-stress myself and relax. That's one place for me.
You're a very good dancer. I've watched it.
Thank you.
Yeah, have you
watched? Oh yeah, I remember.
Yeah.
Just remember. Right.
TEDx NTU. You were dancing. And you danced, right? At TEDx NTU?
Last year.
Yeah, totally.
Very nice.
Yeah, it was very good.
So second would be plants, actually.
Sorry?
Plants.
Yes.
It's very important because I don't know how to say it, because again it was a childhood hobby from me to help my mother with gardening, and over the time it was another place for me to just relax and enjoy. Also researchers said that green color and something like that makes you a bit of calmness, brings some
inside houses,
and also you get excited when I buy something and grows it and gives you a fruit or a flower. It gives you more exciting things.
Okay.
And third is friends.
Okay.
Meeting up with friends.
Social life
is very important.
Okay.
Also, I believe that any person should have at least a hobby. Because PhD is stressful. This is the thing. PhD is stressful. There is no saying that it is not stressful. Of course, it is stressful. Or anything in the world is actually, when you do, is stressful. But having something like this gives you a bit of freedom to change your monotonous way of doing stuff. A bit of away from the thing and then looking at it in a different way. So this is very important.
Has your love for plants inspired your work? Do you think that your choices, your worldview, inspired by your love for plants, or do you think they are not too related?
They are not related. But I, like, from the beginning, like, I wanted to do actually chemical engineering in my bachelor's. I want to do chemical engineering, but somehow the person sitting there turned me to civil engineering. I have no idea how it happened.
Okay.
But now I'm doing actually kind of chemical engineering. I'm happy about it. But back to the question, I was constantly thinking, how can I connect my gardening thing and to concrete?
Right.
Recently, I found out that people like urban designs, and in one of the urban designs actually is like using concrete to make stuff.
Okay.
Like normal furniture, normal designs,
Sculptures,
concrete
artworks.
pots, concrete pots.
Hmm.
And I recently saw some courses which teaches you the same thing.
Okay.
And I was thinking, I did lot of research on concrete, different types of materials. We used dyes to make cool coatings and something like that. And I thought, okay, why don't I learn the course and then do something about like designing? So this is the only place I can find out that these two things matches, like the plans and the concrete.
Concrete, yeah.
Otherwise, it's just like, no, I don't know.
Do you think we're ever going to come to a point where the same way you have a plant, you have this little plant, then the plant grows to be a big tree? Can we have a future where you have a building that you just give it the code and then it builds itself based on some program?
I wouldn't say no, because AI is changing a lot.
Okay.
So we don't know what's happening after 100 years.
I don't know, yeah.
Okay.
So
These days, actually, they have these buildings where they can, just like Legos. I've seen some videos in China.
Actually,
They put them
you
together
can
and-
see the I think the Saraka Nanyang Crescent halls. They are like kind of Lego blocks. They came here and they are saying
Just assemble
them. So that's possible. And the new technology is like you can print the concrete.
I was just about to ask about that. So your material, I guess. I guess. I mean, I've watched a few videos around this. It doesn't seem like it's very fast. As in, I'm not sure if it's no. It doesn't seem very scalable. The 3D printing of buildings. Do you have any thoughts on that?
Right now, according to the researchers, that they can build a house with the 3D printing. They have did something in Europe.
Yes.
I think same way China is also doing some researches. NTU did one.
I think it's a toilet, right?
Yeah, toilet.
Right.
A toilet with 3D printing. I think the technology is developing. The important thing is that you, again, going back to the MITS design, because concrete is highly tailorable thing. Like what you need, you can tailor according to that.
Okay.
So you need a very viscous material which hardens very fast. So researchers are working on that way to find suitable MITs so that we can have a 3D printing thing. Of course, there are so many difficulties, but at least we can build one complete house using this technology that is existing. I can share you some data later. Yeah.
Okay. And that wraps it up for today. Once again, Krishna, we very much enjoyed talking to you about concrete. And you told us about how concrete's not just cement, it's a lot of other things. And you've talked to us about how your work is going to contribute toward making, sensing perhaps better, and also making it more effective to, I guess you call them corners, right? It's easier. It's easier on the pavement, right? So yeah, you can share any other thoughts you want to leave with our audience with. Anything, you're welcome to just say, hey, I love this field because of XYZ.
Thank you so much, guys. Actually, it was first time experience for me, and I was a bit nervous at the first, but this was cool actually.
Yeah, it was really good, yeah.
Yeah, I mean, like when I think about it as a civil engineer, I could say that you think about any cities in the world, first thing that ask you Dubai, what does come to your mind?
Dubai, the Burj Khalifa.
if I talk about China,
Daxing Airport. I haven't been there, but I hear
Great Wall of China.
Yeah, so most of the countries, if you take the main first thing that we come to mind is the building. So that's what exciting about civil engineering is, like you construct something, you make a new stuff, and it would be there for at least 50-70 years. And it's very interesting. Apart from that, for PhD, I would say keep a very open mind, and then like make lot of friends. PhD is just a small chapter of your life, very important, but a small chapter of your life. So keep an open mind, make lot of friends, learn something new during your PhD life. It's very interesting. That's all. Thank you, guys. Thank you so much.
Thank you very much. It was really good
And
talking to you.
that's it.
All right.
Until next time, this is the High Impact Thesis Podcast, brought to you by NTU Word of Wisdom.